Hi guys, my name is Daniel, and for this video I will be talking about my assignment in physics and aerodynamics, and I will be discussing about topics light, wave motion, and sound. And personally, I would like to say first that I'm sorry if there's a lot of stuttering in this video because I don't know how to talk that much. So let's get on with the first one. First topic, we have light and optics. So number one, we have nature of light. So the light waves are a part of a group of electromagnetic waves and radiation. Some examples of it are X-rays and radio waves. It carries certain common properties. It travels at 186,000 miles per second. It also carries energy. It also carries energy from one place to the other. So moving on, in this diagram you can see the electromagnetic spectrum. So from my left we have the radio, and in my right it has the gamma ray. What you can see from the diagram in the middle here, you can see that the wavelength is actually going much more shorter as it goes to the right. So what it's trying to say is that radio has a longer wavelength than gamma ray. But as the wavelength is going through is short as the wavelength is shortened, the frequency increases. So that means gamma ray has a higher frequency than radio. Next, number two, light dispersion. So there are, in a light spectrum, there are actually 7 colors that we know. 6 of them can be identified, which will be red, orange, yellow, green, blue, and violet. The other color is indigo, and it is different from the others because it is very hard to distinguish it. So as a matter of fact, Sir Isaac Newton was one of the first persons ever to explain about these band of colors, these 7 colors. They are known as the spectrum, hence the name spectrum, using a glass prism. Makes sense. So when a light passes from a medium to another, it is actually refracted. So for example, in this one, as we go back, we can see that the white light is going through a medium called the glass prism. So, and in this electromagnetic spectrum diagram, we can see clearly here that the red has a lower frequency than violet. So that means that means that the red refracted the least while violet refracted the most between the 7 colors. So the separation of a white light in this manner is called dispersion, hence the name light dispersion. Number 3, color combinations. So you know, some objects, no, actually all objects appears to be colored. This is because their surface absorbs some frequencies and reflect it to others. Sorry. So this red filter allows light with longer wavelength associated with red color to pass through. There are 2 types of colors: primary colors and secondary colors. So primary colors cannot be created at all, though green can actually be created just by adding blue and yellow, but I'm not questioning any of that. But secondary colors can be created by mixing 2 colors. So for example, in this diagram you can see green and blue can mix together to make cyan white and white. Red and green can also make white and yellow. Blue and red can make purple, and etc. Number 4, reflection. So reflection is the change in direction of a light wave when it bounces off a boundary. There are actually 2 laws of reflection. There's the angle of incidence, which is equal to the angle of reflection, and the other one will be the reflected ray lies in the same plane as the incident ray and the normal line at the point of incidence. So there are two curved mirrors in reflection that I use, and they are called the convex and the concave. So let's talk about the concave and the convex mirror. The concave is mirror is a surface that is shaped in towards the middle and away from the observer, as you can see in the diagram right here on my left. And the convex mirror is a surface where the center is shaped out towards the observer. It is an opposite direction to a concave surface. So using physics law, in the lens diagram, there is always a point P. It is known as a pole, and it is the center of a curved mirror. There will also be a C, which is the center of a curvature, and is the center of the sphere of which the curved mirror is part. There's also an F, which is called the principal focus, or better known as the focal point. Side note here, the concave mirror actually converge, while the convex mirror diverge its rays. Number 6, refraction. So a change in direction of the refraction is a change in the direction of the light ray occurs when light rays move from one medium to another. So I'm just gonna skip this ahead. So what it's trying to say is that when a light passes through a denser medium, it will bend towards the normal line. But if it's going through a less denser medium, it will bend away further than the normal line. So that is refraction. Light refractive index is also light. It's kinda ish in refraction. Its refractive index is you're trying to calculate the speed of light in air divided by speed of light in medium, as it says in the formula right here. So a normal refractive index is 1.33, like in this question, in this example, sorry. So like in a vacuum, light waves travel at 300,000 kilometers, and velocity fails at 200,000. You just divide it and you will get 1.33 as its refractive index. Snell's law. I'm just going to read the definition. The ratio of the sin of the angle of incidence to the sin of the angle of refraction at the boundary of the substances is always constant. Here you have Snell's law. So next will be critical angle and the total internal ray, or total internal reflection, as I like to call it. So as you can see from the text in the diagram, critical angle is when the angle of incidence is equal to the critical angle. The angle is refraction is 90 degrees exactly. For total internal reflection is when the angle of incidence is greater than the critical angle. So it is not a 90 degrees, and all the light undergoes reflection, hence the name total internal reflection. So number 10, lens. There are two basic lenses, convex lens and concave lens, as you have learned before. Sorry. So the distance between the focal point and the optical center is known as the focal length, and is given the symbol f, the minor f. So in this formula right here, you can see that if you want to calculate the power of lens, you just have to divide 1 by focal length of the lens. So in this table, you can see here we have three different categories, which is quantity, positive, and negatives. So for the focal length, in the positives are concave lenses, while the negative is diverging lenses. Yeah, this is because for focal length in a concave lens, it actually converge, while diverge is for convex. In object distance, in for the positive is real object, while negative is virtual object. Yeah, the list goes on, and you can just read here. You can just pause the video if you want to and just read what I just copy paste into from my physics notes. So this will be my first part of the video. Thank you for watching. I mean, this is my first video, so I'm sorry miss if the video is not that great, but I tried my best. This is quite my best. I might do a lot more better in sound. Thank you, miss.